Hello everyone, and today we will explain the homework 1. And if you have some question of the homework, you can send a mail to this mail address. And we will provide you 2 periods office hour. And first is the Monday 2 p.m. to 4 p.m. and Friday 10 a.m. to 12 noon. And the location is at CSIE 9F and robotics lab. Okay. And the following will some regulation you have to pay attention. And first, the copying homework is strictly prohibited. And both of you individuals will receive a Thursday, 9 a.m. And do not submit that, or the following points will be and submit with will be after this period. You will receive a score of 0. And you must attend a demonstration, otherwise your score will be 0. And the demonstration schedule will be announced on NCKU Moodle. And you must create GUI, otherwise your point will be deducted. And when it's time to upload and turn in your homework, you will upload to this FTP IP 140.116.154.28. And the folder path is the upload homework and homework 1. And the user ID is CVDL 2023 and password is RL 2023 CVDL. And the homework format, and you will be paying attention to the file naming method. And the naming method is capital H and lowercase w1, and baseline student ID, baseline name, and baseline version. And this is the compressed file. And if you want to update your file, or you should update your version to be V2. And you don't need to delete original V1 version file. And in this compressed file content is the project folder, and excluding the pictures. And remove your debug folder to reduce the file size. Okay. And next page is the following are some recommended package versions for you to download. Okay. And next one is, and you must be noticed this button, don't fix your image path. And there is another data set for demonstration. And you can use this following function to read the path. And there will be the path to you for reference. And finally, you will use one UI to present 5 questions. Okay, and does anyone have a question? Okay, going to next one. Hello. Okay. Okay, let me introduce the question 1. Oh, okay. Okay. Let me introduce the question 1. There are 5 sub-questions here. Remember, don't fix your image path. You should click this button and load all images in the folder. Next, question 1.1, corner detection. Given 50 image, 1.pmp to 15.pmp. Step 1, find and draw the corner on the chessboard for each image. You will use two functions. One CV2 dot find chessboard corner,
and remember this parameter should be set to none. The second function, corners of pixel, list 3 function usually window size, height and width should be set to 5, and the zero long should be set to -1. It means to ignore. And the criteria have 2 parameters. The first parameter is means to position, and should be set to 0.001. And the second parameter means the max iteration. It should be set to 30. Step 2, click the button 5 corner to show the HP picture. And watching this video, you should demo your code like this. You can also refer to the book OpenCV Textbook Chapter 11. Okay. Next question. And question 1.2, find the intrinsic matrix. Given 15 images from 1 point BMP to 15 point BMP. Step matrix. You will use a CV2 dot calibrate camera, and note the last 2 parameters should be set to none. Okay. And step 2, click the button. Find
this is the function they will use, right?
Yes.
They'll use that function.
Okay, step 2, click the button, find the intrinsic, and show the result on the console window. Your output format is like this picture. Remember, it's just an example, not a correct answer. Okay, next question. Question 1.3, find the extrinsic matrix. Given in extrinsic parameter and the distortion coefficient and a list of 50 images. And step 1, find the extrinsic matrix of the transport from each of the 50 images respectively. Step 2, click the button and show the result on the console window. The output format looks like this picture, and just a sample, not a correct answer. And notice this part. If you should click this button, it should is able to list from number 1 to 50. If you select the number 1, and then 1 point BMP will be applied, and so on. Next question. Find the distortion matrix. Given 15 images. Step 1, find the distortion matrix. Step 2, click the button, find the distortion, and show the result on console.
Just say somewhere you say we should find give the distortion feature coefficients. So the question should be before this one.
And 可是因为这个方程会跟不参数统治出现，所以它可以放在这里面关系，因为它会跟这一题，它会跟这题。
这样是持续的。
好。Click the button to find the distortion and show the result on console window. The output format is like this picture. It's just an example, not a correct answer. Distortion coefficient can be obtained simultaneously with an intrinsic parameter by using calibrate camera function, as I mentioned before. Okay. Next question. Show the undistorted result. Given 50 images. Step 1, undistorted transport image. Step 2, click the button, show the result to show distorted and undistorted image. Your distorted image should be displayed on the left-hand side, and the undistorted image is displayed on the left-hand side. Watching this video, They are slightly distortion here. You use the CV2 function to refine the image distortion. Okay, that's all about the question 1. Does anyone has any question? 或是也可以用中文问，没有关系。Next one.
Okay, the question 2 is augmented reality. Okay. We will given file image 1 to 5.pmp, alphabet lib on board .txt and alphabet lib vertical .txt. The question 2.1 is show a world. We will use for example camera on chessboard. The step 1, calibrate file image to get intrinsic distortion and extrinsic parameters. And the step 2, input a word less than 6 char in English in text edit box in this. And step 3, derive the shape of the word by using the provided library. The question 2.1, we will use alphabet lib on board .txt. And step 4, click button 2.1 show word on board to show result. Each picture for 1 second. Total file image. The question 2.2, show the word camera vertically on chessboard. Step 1, calibrate file image to get. Okay, we will show result video. Camera on board 2.1, version 2.1. And the next 2.2, show word vertically. Okay, the question 2.2, we also question 2.2, we also calibrate file image to get intrinsic distortion and extrinsic parameter. It's also include all word less 6 char in English in the text edit box, except the same word entered in as question 1, question 2.1. And step 3 is also draft the shape of the word by using the provide library. Notice the alphabet lib vertical .txt and click button 2.2 show the word vertically to show the result. It's also each picture for 1 second, and this is result video. And next is to use the library alphabet lib on board and the vertical .txt. We will use OpenCV function to read and derive the array of matrices of the chart. Here, tag K in alphabet lib on board .txt for example. In Python, we will in the K consider 3 lines 1, 2, and 3. So the CH array considers 3 pairs of 3D coordinates in word frame represent 2 ends of the line showing the upright image 1, 2, 3, and the red coordinate is replace red light. The blue one is replace the blue coordinate is represent blue light, and the green coordinate is represent green light. Transport coordinate. Okay, look at this. The transport XYZ axis and 0 and 0 and 0 coordinate are shown in the bottom left image. Each chart should be placed in the order and precision shown in the bottom right image. Okay.
button right.
Button left. Button left is this. Button right. Button。应该是说左边这张图，左边这张图是不在这里。Have any question? Okay, we go next question. Okay. Question 3, stereo disparity map. We can look this user interface. We will load two image separately and use these two buttons. Okay, question 3.1. We will give a pair of image left.png and image right.png like this, and use the button, two buttons. Step 1, we load image left.png, click load image L. And step 2, we will load image right.png, click load image R. And step 3, we will click button 3.1 stereo disparity map to show the result.
Actually, this image number is very complicated.
Okay.
Both images are not good for stereo.
Okay.
Too complicated. Probably should do an easy one. It's very complicated. Okay. Not that good.
The hint, we will use OpenCV stereo PM class to build stereo PM object. We will call CV2 function. We will use stereo is equal to CV2 stereo PM. Correct. The first parameter is non-disparity. It's equal to 2056, and the second parameter block size is equal to 25. The above parameters can be freely changed according to the following rules. The first parameter, non-disparity, is the disparity search range must be positive and divisible by 16. In addition, map disparity range to graph value range 0 to 2055 for the purpose of visualization, like this picture. Okay. The second parameter is block size. It is the linear size of block compared by an algorithm. Must be added and within the range 550. Large block size implies smoother but less accurate disparity map. Smaller block size given finer disparity details, yet increase the likelihood of algorithmic misalignment. If the left image lists in a reference image, the one used to calculate the depth info for each pixel of the image, then the search direction at right image will go find the right to left direction. 3.2. We will given a pair of image L and image R, and the disparity map from question 3.1. The question is clear at left image and draw the corresponding dot at right image like this. We can watch this result video. And this. Okay, the step 1, we will click a left image and draw a dot on the right image at a correct position. And step 2, views should be allowed to repeat and
first. 按太快了，一直跑在前面。
那我重复放。
这个还没放这就走。非常不一样。Click the left, and the corresponding point will show on the right hand side, right?
Yes. Okay. Step 2, user should be allowed to repeat the action 1. A hint is clear at great position at disparity map result from question 3.1. Ignore the position with zero disparity. We will use value case to represent. Like this. This is the position with zero disparity. A value case is this. Have any question?
左右点的位置不对，
动态快速。
对，不能位置都不对。
好，
左边右边，
好，那这边
这张真的做不出来。
And next.
回去把这张打掉，这张好，太复杂。没有，我只把这移上去。
哦，好。Okay, for question number 4, we want to do the SIFT question. And this question's goal is to match two pictures match key points. For 4.1 match key point, first we need to click button to load image. For example, we will load this left image. We can see we want the output is to find the key point of this image. So after we load the left image, we will based on SIFT algorithm and to find key points on left JPG. And we can use the OpenCV's function. First, we need to use SIFT create to create the SIFT detector. Then we use this detector to do the detect and compute the image. And after we found the key points, we want to draw the key points of this image. So we use the CV to draw key points to draw the image. And that's our first question scope. And the output format will like the right side this picture. We can see that we will perform the green dots on this is mean the key points of this image. So this is 4.1. And for 4.2, we need to match the key points. For 4.2, we need to use load these two image. And we need to find the match key point of these two image. A step is like this. First, we need to load the image 1 and image 2. And number 2, we do the same as question 1. We do the question 1 step for each image. Then we can find the two key points of two image. And the third step, we need to find the match key point of these two image. We can use also its OpenCV's function. We use brute force measure, the KNN match. This means this descriptors 1 is the descriptor of image 1, and descriptors 2 is a descriptor for image 2. And what is K equals to means? It means we need to find two sets of measure of these two image. And after we find the two set of measures, we need to extract good match from the third result. In this case, we want the m's distance is lower than 0.75 of n distance. This is in our case goal. And after the step 4, for step 5, we need to draw the match feature key points between two image. The same we will use OpenCV2, CV2 draw matrix KNN to draw the matrix. The final we want the result is like the right side of this. We can see that we can see there's many matches between these two images. So we draw the line between this. Okay, is there any questions? 有没有什么问题？那 next question.
Okay. And in this question, in question 5, we need to training a SIFT classifier using VGG19 with bench normalization layer. And in this question, we have 4 different sub-questions. First, the objective of this question is to learn how to train a VGG19 with bench normalization layer model to classify 10 different class images of SIFT. And first, VGG19 is a convolution neural network that is 19 layers deep. And second, bench normalization layer is used to make the training of artificial neural network faster and more stable. And third, SIFT is a collection of 60,000 32 times 32 class color images in 10 different classes. And the 10 different classes is represented in the slides. And second, this data set can split 3 different data sets. First is training data set. It consists of 50,000 images in total. And second is validation data set. It consists 10,000 images in total. And second, the test data set, we will generate this data set from validation set. And it consists 10 images. And this question's requirement is you need to train a VGG model with bench normalization layer, use PyTorch. And in a submitted file, you need to include 4 different files. First is the weighted file for VGG19 with bench normalization layer in PTH format. And the file size is approximate 540 megabytes. And second is a figure of training and validating loss and accuracy in JPG or PNG format. And third is a code for your GUI program. Fourth is a code for the model training. And this is notice, please do not include image data in the submitted file. And 5 is the images for this question. There are 2 different folders in Q5 image folder. And in the subfolder Q51, there are 9 different images used in Q5.1. And when demo, we will use these same images to demo. And third, in subfolder Q54, there are 9 different images used in Q5.4. These images are used for testing your program. When demo, we will use different images for this question. And this is Q5.1. You need to show 9 different augmented images with their labels. First, you need to use this function to load 9 different images in Q5 image folder. And second, you need to apply at least 3 different types of data augmentation. For example, we use the random horizontal flip, vertical flip, and rotation showing the style. This figure is the 3 different data augmentation image. For example, in this horse image, it's rotation. And in this image, we flip horizontal. And when you demo, you need to click this show augmented image first, and then you load the 9 different images. Second, you apply data augmentation. Finally, you show these 9 different augmented images with label in a new window. And in question 5.2, you can use this function to build a VGG19 model with bench normalization layer. And you can use a torch summary to show the structure in the terminal. This is a figure, for example. And next, let me to explain the structure of VGG19 with bench normalization layer. First, because we use the SIFT-10 dataset, it consists 32 times 32 image. So the input images dimension is 32 times 32 times 3. The 3 means it's a RGB image. And in this model, we have 5 different pooling layers. And each pooling layer will reduce the dimension of the feature map by both the height and by half both in height and width. And any convolution in this model, the filter size is 3 times 3. And after each convolution layer, we will pass the feature map into a bench normalization layer and a value activation function. After passing 5 different pooling layers, the feature map size will reduce into 1.1 times 1 times 512. And next, it will pass into adaptive pooling. It will be resized into 7 times 7 times 512. Next, it will be flattened and pass into 3 different fully connected layers. And it will output a vector of size of length 10. It means the class probability of 10 different classes. And let me explain the figure about the structure of VGG19 in terminal. First, the left is a layer type. It means the layer type of the model. For example, the bench normalization layer 2D38 means a bench normalization layer, and it's a 38th layer in this model. And second is feature map shape. There has 4 different number to this part. And the first one is mean bench, and second is channel, third is height, fourth is width. And the first channel bench is -1 in this, because the -1 index, that's the actual size of bench size can vary. It means in your after you channel, you can change the bench size of this. So the -1, if you set the bench size to 32, it will be 32. If you set into 64, it will be 64. And the third is the number of parameters. It means the number of parameters of this layer. And in this question, when demo, you can click the button to show model structure, and it will run the torch summary this function to show the structure in the terminal, just like this. And in next question, you need to show the training and validating accuracy and loss. And at home, you need to use this function to load the training and validation datasets, and then training and validating VGG19 with BN at least 40 epochs. And next, you need to recall the training and validating accuracy and loss in each epoch. And if your validation accuracy is low, you can try to change the learning rates of the optimizer or change the data augmentation techniques used. And after training the VGG19, you need to save the weighted file with highest validation accuracy. And next, you need to use this function to create a line chart for the training and validation loss and accuracy. And you need to save this figure. And below is the example about the figure of training and validation loss. First, this is a loss chart, and the blue line is a training loss, and the orange line is validation loss. And the next figure is an accuracy line chart. And notice this is an example. The number of epochs might differ. Next, you need to use the model with highest validation accuracy to run inference and show the predicted distribution and class label. First, you need to load the model which trained at home. Next, you can click the button Load Image to display a new file selection dialog, and you can select one image. Next, it will show the selected image on the GUI. And notice when you display the label image, you need to resize the image to 128 times 128 because the original image size is 32 times 32. It's too small and it cannot display clearly on the GUI. And fifth, you can click the Full Inference button. And next, it will show the predict class label on the GUI. For example, this image is a deer image, so the predict class label is deer. And next, you can show a probability distribution of model in a new window. And this page is this class probability figure. The coordinates of y represent the class probability. It's from 0 to 1. For example, this image is a deer image, so the class probability of deer is higher. And the second is horse, because deer and horse is similar. And the coordinates of x represent the class name. And final is the demo video for after you finish this question. When you demo, it represents. First, show the augmented image. It will show 9 different augmented images. And second, show model structure. It will show a model structure in the terminal. And third, it shows accuracy loss and accuracy. And final, we can load the image first. And then click inference button. It will show the class probability. And when demo, we will select different images to inference. And my explain of this question is end. Is there any one question?
Okay, if you don't have any question, that's for today's class. So this homework need to turn in 2 weeks later. Okay, so thank you for today's class. 那个 office hour 你有问题可以问了哈。